Students, today we start a problem from the chapter of work power energy. Here it is given the work is a function of x and it acts on a particle in the x direction. Where A and B are constants, these two are constants, and find the work done by this force for a displacement of x equal to 0 to x equal to d. Now, only one small thing to be noted here, that force is equal to, force is a function of x. So normally we use the equation work done is equal to force multiplied by displacement. Here, in this equation, force is a constant. So, if the force is a function itself, then this equation cannot be used. If force is a function of s, obviously we have to use the concept of integration. So, we'll go by that concept of integration. Here, original equation is W equal to Fs. So in the term of differentiation, the equation will be dW is equal to Fx and dx. This Fx means f is a function of x itself, which is given. So therefore, if you integrate both sides, total work done is equal to integration of Fx, and here they have taken the parameter x for displacement. So instead of ds, we write dx. And we have to see the limits of x. Here the limits are given. Here the limits are very clearly given from x equal to 0 to x equal to d. And what is fx? Fx is also given a plus bx. If you do this integration, then what you get is a, integration of a is ax, plus integration of b is bx squared by 2. And the limit of integration is 0 to d. Fine? So this is equal to a into d plus d square by 2. Minus terms are 0 because here x equal to 0. So this is equal to, if you take d common, a plus b by 2 whole multiplied by d. This is a very simple question, but just the concept of integration has to be used here. Okay? Now we go to the next problem. This next problem it's problem number 11 of your textbook. Problem number 11 of your textbook. Here. The problem is a box weighing 200 Newton. So weight of a box is given. A box weighing 2000 Newton is to be slowly slid through a 20-meter distance on a straight track having friction coefficient 0.2. So the problem is clear. The problem appears to be like this, that there is some table or some floor. There is some table or some floor here. which box is to be. It's like a box. Okay. Now, this box weighs 2000 Newton. So mg is equal to 2000 Newton. Do not consider it m. This is mg since the unit is given Newton. Has to be pulled through a distance of 20 meters. Distance of, say, 20 meters. On a surface having a friction 0.2. So on this surface, mu equal to 0.2. The question is, find the work done by the person pulling the box, find the work done with a chain at an angle theta with the horizontal. This is the point. That means the boy is pulling the body with a rope or chain, whatever it is, at an angle theta. At an angle theta. It is not a straight horizontal force. We have to find out the work done here. Right? Now, once again, if we try to visualize the free body diagram of this box, then this has a weight force downward of 2000 Newton. And this force, let us consider this force is F. This force has two components. This is F cos theta, and this is F sin theta. F sin theta. Okay? That means a component of the pulling force is also working in the vertical direction against the weight force of the body. And also there is a reaction force R, and the frictional force F. Frictional force, if I am trying to pull this in this direction, then frictional force F in this direction is equal to mu R. Fine? Then let us find out the force components, and the actual work in this kind of a problem is to find out the force components correctly, and then in rectangular components. That means mostly we do it in horizontal and vertical, and then just equate the horizontals and then equate the verticals. Here, if we go to the vertical, we find R plus F sin theta is 2000. So we find R plus F sin theta is equal to 1000 Newton. Right? This is one equation. And another equation we find that this F cos theta in horizontal, there is a force F cos theta in this direction. There is a force F equal to mu R in the opposite direction. So we write F cos theta has to be mu is given 0.2 and a reaction R. Right? So from this equation, from here, we can write that F cos theta equal to 0.2. What is R? R we find from this equation. From this equation, we find value of R. R is 2000 minus F is 2000 minus F sin theta. From here, what we get? F, if we take within the bracket, outside the bracket common, F cos theta, this F sin theta will come on the left-hand side with a multiplication of 0.2, F cos theta plus 0.2 Sin theta is equal to 0.2 multiplied by 2000 to 4. So here we get is equal to 400 divided by cos theta minus 0.2 sin theta, right? So this is the force. This is the force F that we have found. Now, what is the work done? This is what they wanted to know. What is the work done? The work done by the force. Work done is the body is moved in a horizontal direction. So we have to take the horizontal component of the force into account. So work done will be F cos theta multiplied by 20 meter. Work done is equal to F cos theta multiplied by 20 meter. This is equal to a value of F is given here. So what we have 400 multiplied by 20 cos theta divided by cos theta minus 0.2 sin theta. This is equal to 8,000 cos theta divided by cos theta minus 0.2 sin theta. Now, here in this equation, I have cos and sin, two different type of trigonometric parameters. If I divide both numerator and denominator either by cos or either by sin, then I will have only one parameter. Let us say I divide it by cos theta. So here then I will have 8,000 divided by this cos theta also divided by cos theta 1 plus sorry, I have done a mistake here. There was a plus sign, so this is a plus sign. I have done this mistake here earlier. 1 plus 0.2 tan theta. Further simplify it. I multiply both numerator and denominator by 5. So it will become 40,000 divided by 5 plus tan theta. So this is one answer. Second question is, find the work done when the person has chosen a value of theta which ensures a minimum magnitude of force. That means the person can now decide to change the angle of theta. Now he can either pull it in this direction or maybe in this direction. We can pull it try in various directions. We also do it in our daily life. Our brain automatically finds out the angle where the pulling force is minimum. So we have to find out the theta when this force is minimum. When the magnitude of the force is minimum. What is the magnitude of the force? This is the magnitude of the force. So we can say that force will be force will be minimum when the denominator is maximum, when cos theta plus 0.2 sin theta, this parameter is maximum. Now, how do you find out the maximum, minimum? I think you have already learned in your differential calculus classes that at maximum, any function will reach maximum when differentiation of that function is zero. This happens for minimum also, but then further double differential is positive and negative and such complexities are there. But it is not so difficult. Here, we differentiate this thing, cos theta plus 0.2 sine theta by theta, and equate that differentiation to zero to find out the value of theta, right? So if we differentiate this, will be a maximum. F will be minimum when this is maximum. That is, you can write when theta of cos theta plus 0.2 and theta is equal to 0. So, right from here, we can say differentiation of cos theta is minus sine theta and plus 0.2 is a constant, and differentiation of sine theta is cos theta is equal to 0. That means minus sine theta plus 0.2 cos theta equal to 0. So if we take sine theta on the right-hand side, so therefore here you can say that 0.2 cos theta equal to sine theta. From here we can say tan theta is equal to 0.2. That means the applied force, required force will be minimum when theta is such that tan theta is equal to 0.2. Right? Therefore, then the work done equal to 40,000 divided by 5 plus 0.2, because tan theta is 0.2. If you calculate this with your calculator, it will be 7692. Of course, unit is joule. Okay. So this was not a very difficult question. And then we shall go to the next equation after a few minutes. Next problem sum after a few minutes.